Hey everyone, I'm Manos. Can you hear me? Awesome. So this presentation is going to be all about capabilities, which is essentially building access control on chain. Now, let's go over the agenda. We're going to talk about what capabilities are. We're going to see how we manage capabilities. We'll see some tooling we use day to day, and also some examples of capabilities. Before we start with capabilities, let's say one phrase again and again. Everything on Sui is an object. And because everything on Sui is an object, that's how we have capabilities. And that's how we have the special ownership model of Sui. So let's talk about it. We have true ownership, and we can have an address that owns an object. That's the purest form of true ownership. We have object ownership. That means that an object can own another object. That's usually done through wrapping an object. That can be done with transfer to object, which is a new feature, or by using dynamic fields. Then we have immutable objects. Here, ownership is interesting because it's everyone. I own these objects, you all own these objects. The only catch here is that nobody can mutate them because they are read-only. And last, we have shared objects. Here, everyone owns them again. I own them, you all own them. But we can all mutate them. Now, let's move into capabilities. I actually tried to create like a super localized example on capabilities. So I will build my own chain bakery, since we're in Paris. The goals of this bakery is to actually sell croissants. And it's also for me to make some Sui. So I will also be holding a balance and sell those croissants to you. Now, as we understand, since I want every one of you to go into this object and actually purchase those croissants, I guess we need a shared object that anyone can go in and we can mutate it because we're adding balance. Now, can you spot the problem here? If that's the case, then what stops you from going in that shared object and actually taking the balance away? And this is where, I actually want you to see this meme. This is where capabilities come in play. So capabilities are objects, again, that actually allows us to add some on-chain access control on different functions. They are our authorization, and we can choose how we build them through our smart contracts. So we can indeed build some complex logic and actually gate actions based on object ownership. Now, that might sound like a lot of trouble. We have an object that gives you access to another object, but that's 50 lines of code, and it does the entire on-chain bakery that I'm running. Now, let's look at it step by step. Here, we have a bakery. That will be our shared object in this case. This bakery has a balance, and it also holds the price of those croissants. Then we have the bakery cup. This is the capability that I will probably hold because I'm the one publishing the bakery, and these croissants that you will all be purchasing from my bakery. Now, we have the init function. This function is always called automatically when we publish a package. And in this case, in this on-chain bakery, we can see that we have a bakery being created there, and it's being shared. So that's our shared object, which holds the price of 1 Sui per croissant. It's also affordable. And it also creates a bakery cup, which is sent to the sender of the transaction, which is essentially me. Now, if we look at the public-facing functions, we have a purchase function, which we will all be calling later. And it takes a bakery, a shared object, anyone can pass it in the function. It takes a payment, a coin. It checks that the coin adds up to the price I've set, and merges it in the balance of the bakery and gives you the croissant. Now, the second function we have in my on-chain bakery is a withdraw function. This withdraw function, as you see, the first parameter is the bakery cup. This is my capability. And that actually stops you all from being able to withdraw from this shared bakery object. Now, let's grow into a V2 bakery. I mean, we have established that I have the best croissants in town, and now I want to give some better prices to some wholesale partners or, I don't know, make some special deals. With capabilities, we can also have built-in logic. I will actually run through an example immediately for that case. And let me move to this side so we can see it. And this example is actually a special capability that gives a fixed price, which is different from a shared object price, for a specified quota. Let's say that I want to sell for 0.5 Sui for 1K croissants and no more. Here, as we can see, I've built this special capability. It's called wholesale cap. It has a quota, it has a price, and how many croissants I've used it for. And then we have a public function, which we can use the bakery cap, which is like a master capability in my case. And I can mint multiple wholesale capabilities with a specified quota and price. So that gives me the flexibility to create multiple wholesale caps with different configuration. Now, again, if we saw an example in reality here, when you had this wholesale capability, you would be the only one, the holder of this capability that can call the wholesale purchase function, pass in the capability, pass in the bakery, which is a shared object, and we do some checks and we give you the croissant. Another example is a time-based capability. So that means I will give you 0.5 Sui, but only for a week. So you have 1 week to buy as many croissants as you want for 0.5 Sui. Again, we do something similar. We have a mint wholesale cap that only me, the bakery cap holder, can call. And here we only add an extra check that we are actually using a date in the future. And the checks would be similar. Now, let's actually move into another nice thing about capabilities, and that's how we manage them. It's always a thin line how we manage on-chain things, because we have security and we also have convenience. I mean, that's a way to save our private keys. That's the basic form of how we actually hold our assets. We have a Sui address. A private key, a Sui address is derived from a private key. So we need to somehow secure our private key. And there are, of course, different ways we can secure our private keys. You would hear many different thoughts here. I would argue that more probably hardware wallets are the safest solution, but there are also some key management solutions we can use. But for this example, my question is, should I rely on a single address to manage my entire bakery? Because as we saw in the examples, with the same capability, I could withdraw the profits. I could create multiple capabilities for other things. So should I? The answer is not actually that simple, and it's our favorite phrase, especially for engineers in the room, which is, it depends. And why it depends? Let's actually see some more cases. Even though I've been pretending that this is my bakery the whole time, I actually have 2 more people I run this with. And now we need to decide who can withdraw these profits or do any of the other actions on that bakery. This is where we have Sui multisig. With multisig, this is native to Sui, by the way, we can have multiple private keys that correspond to a single address. And they can also be built with different weights. So one's signature is actually more important, I would say, than the others. So in my example, where we are 3 in total, we're 3 founders of this bakery, we can say that we all trust each other 100%, and we create a 1 out of 3 multisig. In this scenario, any one of us could go ahead and actually sign a transaction to withdraw the profits or create more capabilities. But let's say that we're a little bit more cautious and we say that at least 2 of us have to agree. With multisig, we can create all these different combinations. We can say that I want a 2 out of 3, a 3 out of 3, or play with weights and actually create more complex scenario. We can also imagine a scenario where I use multisig as my 2-factor authentication. I have my primary private key on my laptop, and I also have I save a private key on my phone, and I can actually need to sign with both my first private key and my phone, or even more devices, as you understand. And another great thing with multisig is that we can actually build processes If we are running an organization, for instance, we can have a fixed way on how we validate and execute transactions for different actions that we need to do. This small diagram is an example on how we do multi-sig at Mysten Labs. So let's actually try and walk through an example through that. Let's say that the sample there is actually withdrawing some funds from the bakery. Then we usually generate the transaction data with GitHub Actions so that we all know that the code that has been checked in is actually peer-reviewed. And apart from that, when we actually send the transaction to the signers, we can have multiple signers, they can also validate the transaction because they can dry run it. So they can preview the effects when they actually sign and the transaction is eventually executed. That's almost always the case. With randomness, you cannot really predict the effects always, but it will work for most cases. So after we collect all the signatures, let's say that we have a 3 out of 6 scenario, then we're at this stage where we need to actually combine the signatures, verify that we have all the policy checks. Let's say that I want to execute this transaction after 9 p.m. today and not yet. And then we can broadcast it on the network. This is just a sample, but you can imagine that you can be creative on how you do these operations in your org and in your case. And that's generally a weekly thing for me. Now, we have established our multi-sig process. Everything is great. We know how we can withdraw or create capabilities. But now there is another company that was impressed by our croissants, and they want to buy in. They want 50% of our bakery. Now, in this case, we can actually withdraw the profits or do any of the other actions we have. Now, the answer for that comes from the flexibility of Sui's object model. And that's because of the ownership model. So if an object can be wrapped by another object, can be owned by another object, that means that we can build our access control on the parent object as well. And in that way, we can create on-chain quorums for these situations. Let's actually see an example to understand this a little bit better. In this diagram, we say that we have a wrapper object, we can name it anything, that has a quorum. It's a 2 out of 2. It's both me and my 2 other founders with our multi-sig, and the other company with whatever way they have decided they do the process of signing. Here, we can propose different actions on our bakery quorum. Let's say, like, withdraw 500 Sui and transfer it to my address. And here, we need to agree, both us and the other party and the other company. So we need to vote on chain, and once enough votes have been gathered, we can actually execute this transaction. Now, let's also discuss a special case, which is that of managing capabilities on backends. Here, we want to execute things fast, most likely. So we can't really go with multi-sig solutions, or we can and can't go with quorum solutions. So let's assume that our game server needs to mint some objects based on some game state that's not on-chain. I will just give some things to look out for when we do that. And that is that we need to make sure that the capability that's held on our backend always has some limits, so we can actually revoke it in case we have any breaches. That could be that we set some limits. As we saw before, we could set a time expiration, or we could set a maximum amount of mints before we actually need to create a new capability. We can do capability versioning. That the only drawback here is that we have to go through a shared object to keep the right version. But that way, we can actually invalidate all the issued capabilities with one transaction as the game admin. Or we can do whitelisting, which has, again, the same drawback of not being able to go directly through fastpath. But we can indeed decide to revoke a single capability and not all or nothing. And generally, the capability that controls other capabilities should be kept in a safer solution, because breaching that becomes a problem. Now, let's move on to some of our tooling. we have the multi-sig toolkit. This is a tool we've built to actually preview, sign, combine, and execute transactions. This is essentially what most of our multi-sig signers would see when they were signing a transaction. They would go into this toolkit, they would paste the transaction data, and they would be able to see the effects in a beautified way and understand what they are signing for. So in this example, for instance, we can see that there are 2.7K Sui being transferred to 0x Manos. You can actually scan the QR code if you want to see this toolkit. By the way, previewing effects is not the only thing. You can also combine signatures there and broadcast a transaction once you have the signatures. And then we have the quorum package management. This is from the quorum solution we discussed before, and this is for packages. Packages are also controlled by a capability, and that's named upgrade cap. That's the capability that controls a package upgrade. Even though the upgrade system of Sui gives some assurances, for instance, that your code will never change, because our code is also an object and it's an immutable object, we also need to make sure that whoever can authorize these upgrades is someone we trust, because we generally tend to trust advanced versions of the same package. Let's assume that we have a DeFi project with really high volume, really high liquidity. Can we always trust just the author to authorize upgrades? Can they just upgrade and add the function that allows them to actually withdraw the liquidity? Again, it depends. I don't have a clear answer to this, but for these reasons, we actually decided to create this quorum package management, which allows you to have a quorum solution with different voters. You can set it up. You can say that I want to have a signature, a vote from the package author, from an auditor, for a third-party organization, from a community member. Anything would work. Here, you can also scan this QR code. This will have the smart contract, all the reasoning behind why we built this, and actually also has a dashboard for no-code integration and voting. And last but not least, we have some examples. Actually, it's only a single slide because these examples are everywhere. So if we look at this slide, we can see that we have coins. For coins, we have treasury cap. The treasury cap can mint, burn, or update the coin's metadata. For display, to create the display, we need publisher. Publisher is a capability that we can create when we're actually publishing the package. And that is the proof that we published the package. So to create a display, we're essentially the creator. Packages, again, we talked about them before. We have the upgrade cap. Then we have kiosk, which is our commerce framework. Kiosk can have multiple objects, multiple NFTs that are for sale or for holding if it's on a locked state. And to manage our kiosk and actually collect our profits, we have the kiosk owner cap. And then we have transfer policy, which is a nice combination because we have the publisher object, similar to display, that allows the creator to create transfer policy. And the transfer policy itself has a transfer policy cap that allows you to actually add or remove rules to this transfer policy and also withdraw profits. As you understand, there is a lot of composability, and there are many different ways we can build and design our systems to make capabilities work and also make sure we allow as many functionality as we want for a particular object. And that sums it up. Thank you all.